Okay, so this is Algebra 1. Today's date is Wednesday, October 2nd, 2019. I am recording this at home because I am at a math teacher meeting. Today we were doing 2-10 Compound Inequalities. These are notorious throughout Algebra 1 as being one of the hardest things to deal with. And I also made it additionally harder by accident by not teaching you how to graph simple inequalities yesterday. So that is my bad, and I apologize to all of you. So it's going to be kind of a hard lesson. And when I say kind of, I think it's going to be the hardest lesson for the entire unit. So going forward, really help your peers. Just really try to understand what's going on in this lesson. I'm going to guess that a lot of people are going to be confused and are going to ask questions tomorrow. And I know that tomorrow is theoretically our quiz. Let's come back over here and look at Algebra 1 or Unit Guide. Yeah, so technically tomorrow's our quiz. I might have to move that back if too many people are confused, but hopefully we're ready for the quiz by tomorrow. Alright, so let's get on with the notes. Today's objective is to solve the combination of two inequalities, and they're going to be joined with or and. So let me teach you how to graph inequalities, which is what I should have done yesterday. So again, this symbol is less than. So what type of point is this? And if you look up on my cabinets, so if you're looking at the front of the room in the back left, there are some cabinets up here that have these definitions that will be up for the quiz and the test. If it's less than and not equal to, it's an open point. If it's greater than and not equal to, it's an open point. If it's less than or equal to, it's a filled in point, so a closed point. And if it's greater than or equal to, it's a closed point. And if it's not equal to, it's an open point. So notice the pattern here. If you ever have an equal sign, then you can be equal to that point. But if you say, I can never be equal to it, these can never be equal to it, so there's an open point. You don't have to know this, but this is called open, and this is called closed. Later in, I guess next year, or if we ever come back to inequalities again for Algebra 1, you will have to know those. So you might as well just learn them now, I guess. So what direction does the arrow go? And when I say arrow, I'm talking about all the possible solutions. And it'll make sense when we talk about example 1 and 2. But if it's less than or equal to, I'm going to the left. It's kind of like an arrow. If you make an arrow, it's going to the, sorry, it's the reverse arrow. If it's less than, that means all the stuff, no, yeah, that's correct. It's an arrow. It's all the stuff to the left of that. So this is stuff to the left. And if it's greater than, it's all the stuff to the right. Think of this as an arrow that says everything to the right-hand side is good. This is right. And then, again, it's an arrow to the left, an arrow to the right, and there's no direction here, so none. Or I guess, instead of saying none, I think a more technical term would be both. Both to the left and to the right. Just not at that point. So it's everything but that point. So let me give you an example. If I said x is less than 3, then I would have an open point at 3, and then I go to the left. So if I had a greater than symbol, it would look like this. A less than or equal to symbol would be a closed point that goes to the left. A greater than or equal to is a closed point that goes to the right. And a not equal to, it looks kind of funny, but it's an open point with arrows both to the left and the right. So it's basically anywhere where there's an arrow, that is a solution. So this is a solution, this is a solution, this is a solution. All of those are solutions, which is kind of cool for the not equal to, which means everything is a solution except for that one point that I'm talking about, which makes sense because there are an infinite number of solutions. If I say, what numbers are not equal to 2? Well, 1 is not equal to 2. 3 is not equal to 2. 7 is not equal to. Anyway, there are an infinite number of solutions, which makes sense with our graph right here. All right, let's move on to example 1. I need a graph x is greater than 1. So I'm going to come up to 1, and on the number line, actually I can do it above it or I can do it on it. If I do it above it, it's a little bit more clear, so I'm going to do it that way. It's clearer, I should say. So if it's greater than 1, is it a closed point or an open point? And you should say, oh, if it's greater than, it's a closed point. So I'm going to do a closed point above 1, and then next question is it to the left or to the right? If it's greater than 1, or if there's an arrow, you can think of the arrow, it's going to be going to the right. What this arrow represents is all the possible solutions. So what number could be x? 2 could be x, because that is part of the arrow. 3 could be x, 4 could be x, 5 could be x, and since there's an arrow, 100 could be x, because 100 is greater than 1. 1 cannot be x, because 1 is at this open point. 1 is not greater than 1. And 0 is definitely not in here. It's not in the arrow, so 0 is not less than 1. Hopefully we're making sense so far. I don't have any feedback, so I'm just going through the video. Let's try another one. X is less than or equal to -3. So here's -3. I'm not going to make a open point or a closed point. And you should come up to your table and say, oh, okay, that's a closed point. So filled in point. And then think of your arrow. I'm going to the left because I'm going less than or equal to, and there's my arrow. And it doesn't matter the size of your arrow. You can make it tiny, you can make it really long, it doesn't really matter. But it's saying that -3 is a solution because -3 is less than or equal to -3. -3 is equal to -3, so it is a closed point. -4 is a solution, -4.5 is a solution, -5 is a solution, -100 is a solution. All of these are the solutions. This is a graphical way of representing your solutions. The reason I'm teaching you how to graph is because it makes it really, really easy to combine these two different inequalities. I can now combine this one with this one just by looking at the visual graphs. Let's talk about how we're actually going to combine these. So I can combine them with or and. So the general idea, and this is, if there's one point that I really want to drive home today, it's these two facts. Or satisfies one inequality, and satisfies all inequalities. And since we're dealing with 2, I could have changed that to say 2. But since, it's the same difference. So what do I mean by this? Let's do a graph over here. So if I have 2 graphs, let's say I have a graph that goes like this, goes this way, and a graph that goes, I'm just choosing kind of a random graph here, just totally at random. If I did or, let me move these because I'm talking about both of them. If I'm doing or, one inequality, where do I have at least one arrow? Well, this is a solution because it satisfies, it hits the line at least once. This line right here, it touches at least once. This is also a solution. This is also a solution because it touches at least one of the lines. It satisfies at least one inequality. It happens to satisfy both of them, but at least it satisfies one. So that's a solution, this is a solution. All of these are solutions. Notice that anything over here is not a solution. So or is anything to the right. This is or. But for and, it has to satisfy all the inequalities, and since we have 2 here, it has to satisfy both of them. So here, this is not a solution because it does not satisfy both this graph and this graph. Wherever you see 2 lines, one on top of each other, this is the first solution that you have. And then all of these are solutions as well, but not these, which means my and, if I combine these with and, it starts right there. That is our and. Okay, so this is the point where you might need to pause the video and talk to a neighbor and say, what the heck is Mr. Sindel talking about? Do you understand what's going on? If you don't understand, hopefully you can stick it out and it'll make sense when I'm talking about these possibilities. By the way, this table represents every single possibility you will ever see for this this homework and this type of material that will be on basically any problem ever. It's all 8 possibilities. 4 possibilities for or, 4 possibilities for and. I just chose random circles here. This one was open, this one was closed, and I did the same thing over and over again so that everyone can kind of see the same thing. So if I'm combining this inequality and this inequality, what's going to happen when I use the word or? I'm combining these 2 graphs, and I'm using the word or to combine them. Notice that this arrow right here goes actually forever and ever and ever, so it eventually does touch this one. Again, or states, if I come back here to my graph, it has to touch at least one of the lines. So that's a solution, that's a solution, that's a solution, that's a solution. Even though it's touching 2 lines now, it's still a solution because I'm touching at least one line. So where does the solution begin? Well, it begins back here at 4. The solution here starts at 4, and goes to the left. So if I combine these two with OR, it turns into just this one graph. And that's the whole point of today's lesson, combine two graphs to make one graph. How do I do that? Okay, let's try the next one. So if I extend these lines, nothing really happens. Extend that line, nothing really happens. I ask myself, is that a solution? Yes. Is that a solution? Yes. Is that a solution? Yes. At 1, it's not in a solution because it's an open point. So I know that all of those are solutions, but not at 1, so I can graph that. Again, if I'm using the word OR, that means it's wherever I cross just one line or 2 lines or 3 lines. It has to cross at least one line. Is this a solution? No, it doesn't cross any line. Is that a solution? No. Is that a solution? No. But right here is a solution, here's a solution, here's a solution, including 4. These are all solutions. So my graph looks exactly the same as the original graph, which is kind of funny. And that is a possibility. It'll look exactly the same when I combine it with OR. Let's try the next one. If I'm combining these two functions, again, I'm extending this arrow all the way to the right, and I ask myself, where do I touch at least one line? Here? No, that doesn't work at 1. Here doesn't work, here doesn't work, here doesn't work. Here works, I'm touching at least one line. Here also works, I'm touching at least one line. I happen to be touching 2. It's kind of like the reverse of this first one. So the answer here is, I can't be at 1, but everything to the right of 1, that is a solution. And our last possibility for OR is, what if you're going this, you're going to the right from this point, I'm going to the right, and I go all the way. It doesn't stop. It continues all the way because this arrow says, go to infinity to the right. Similarly, I can do a different color. This arrow is going infinity to the left, which means this arrow will go all the way out here towards infinity. This blue arrow will go all the way out to the right towards positive infinity. This is all solutions. Look, this touches at least one line. This touches at least one line. This way over here touches at least one line if I extended the yellow line out. This touches at least one line. There's nowhere that you could draw a line that is not a solution. It is all solutions. You don't even need to graph it. You can just write it out. It's all real numbers. Everything is an answer. No matter where I go, everything is an answer. There's at least one line everywhere. Okay, let's switch to AND. AND is a little bit trickier. AND requires, again, coming back to review, to touch both lines, all of those lines, at least 2 lines in this case. So I'm again going to extend our arrows out a little bit so we can see where they cross. So where do I cross at least 2 lines? Well, that's only one line, that's only one line, that's only one line, so those are not solutions. That's only one line. Oh, this is our first solution. We finally touch 2 lines, 2 lines, 2 lines, 2 lines. So our solutions seem to be right there. Basically what we've said is everything to the left at 1, to the left of 1. The question I have for you now is 1 included? Is it an open dot or a closed dot on our actual graph? And you might think, okay, well, 1 is not included here, but it is included on this extended blue line, and it has to be included twice, so it's not a solution. If it's included twice, if it's 2 arrows or 2 lines, then it is included. Since I'm not including 1, there's no 2 arrows, so your answer is going to look like this, open dot to the left. Let's try another one. Where do you have 2 lines that overlap? Well, this one goes out forever to the left, this one goes out forever to the right. Do these ever overlap? The answer is no. If there's no overlap, then there's no solutions. No solutions. No matter what you do, nothing will satisfy both this and this. Alright, let's try another one. Again, extending the line, It's going to be very similar to this first one, kind of reversed. So where do I have double lines, double overlap? Well, not here, not here, not here. I still only have 1 line. Oh, here I have 2 lines. I include 4 and this extended blue line. Here's an answer, here's an answer. These are the possible answers because that's where I have overlap for the AND. So our answer, it starts at 4. That's the first overlap with a close point because I do include 4. That is the original overlap, and it goes out to the right. And our final possibility, what if I go out forever to the right from 1 and out forever and ever to negative infinity to the left from 4, where is the overlap? And this one is also kind of a cool question. So I don't have any overlap here. There's no overlap, no overlap. Still no overlap exactly at 1, but now there's overlap. Now there's overlap, good overlap, good overlap. So our answer is everything in this region. And then all of a sudden over here to the right, there's no overlap, so no more solution. Our solution is only in between 1 and 4. So between 1 and 4. Now the question is, are these going to be open or are they going to be closed? Are they going to be filled in dots or are they going to be not filled in dots? Well, I didn't have any overlap here, but I did here. I had this blue line and this yellow line all happening at 4, which means we're going to have a filled in dot here at 4, a closed dot at 4. So let me back up here to make my notes not so messy. So I have an open point at 1, a closed point at 4, and the answer is everything in between there, which means there's no arrow, it's just a line. And that's the answer. I can come back here and change that back to blue so it's consistent for my notes. So this is the graphical way of doing and or, how to do compound inequalities. I have to talk about notation. I know I want to let you try a problem, but I need to talk about notation on what happens when you have something between two numbers and when you have a gap. So if I'm between two numbers, the way that I write that is that, let's say that this is talking about x. So I'm going to say that x, where does he live? X lives between 1 and 4. So 1 is less than x is less than 4. It's a compound inequality. There are two inequalities compounded together. They are next to each other. Now the question is, which of these are less than or equal to, which of them are just less than? And again, I'm coming all the way back to my table. Notice that a less than or equal to is a closed dot. A less than is an open dot. This is a closed dot, so this should be an equal to. This is an open dot. It should just be strictly less than, not equal to. That's how you write it out. So you'll be seeing this form over and over again on Khan Academy. This one is a little bit trickier. This one, well, maybe it's even easier. I think this one is a tricky one. You just do this with an or in between it. The only way that you can get this graph, notice that this graph is unique on the solutions for the answers. There's only one of these that go out in different directions with an empty space in between, and it happens with an or. So you literally come down here and say an or again, and you can say less than 1, so x is less than 1, and it's equal to, because I have a closed point, and or x is greater than 4. That's how you say it. It has to use an or. If you say an and, you're saying it incorrectly. Alright, finally, we can do example number 4. I know we're like super long into the video, and I apologize. It is a long lesson. If you end up not finishing this lesson, you can finish it tonight for homework. Solve for x. So we've done this before. Let's go ahead and do it. I'm going to subtract 3 on both sides, minus 3. I'm going to solve this one, get an equation, solve this one, get an equation, and I'm going to graph both of them on our number line. When I subtract 3 on both sides, 3 goes away. I'm left with 2x is still greater than or equal to 9. I haven't multiplied or divided by a negative, so it doesn't switch a sign. And then finally, I'm going to divide both sides by 2. Wait. Teacher error, isn't there? 9 minus 3 is not 9, it's 6. That's my bad. If you caught it, log it in your extra credit tracker. I'll come sign it later. Divided by both sides by 2, because 2 is a coefficient. 2's cancel out. And 6 divided by 2 is 3. Did I divide by negative? No, I divide by positive, so it still doesn't switch the sign. I get x is greater than or equal to 3. Well, let's go ahead and graph that right now. So here's 3. It's equal to 3. Greater than or equal to, so it's going to be a closed point, and make the arrow, it's going to the right, so going to the right. There's my first function. Let's try another one. 2x plus 7 is greater than 17. I'm going to subtract 7 on both sides of the inequality, and the 7 cancel out. I'm left with 2x is greater than 10, and then from here I'm going to divide both sides by 2, divide both sides by 2, and I get x, because the 2's cancel out, is greater than 5. So I go ahead and graph that. X is greater than 5, so it's an open point because it's not equal to. If it was equal to, then I could fill it in. And it's going to make the arrow to the right. It's going to the right. Alright, now that I've graphed this, I'm going to come back and use my table, or if I just use some logic, or means wherever I have just one line. So I have at least one line there, so that's an answer. I have one line there, that's an answer. That's an answer even though it hits 2 lines. At least there's 1 line. That's what OR means. There's at least 1 line. So if I turn this into my final answer, I'm going to do it in the red. My final answer is exactly this one right here. My final answer starts at 3 and goes to the right. And how do I say that with an inequality? I come back to my final answer and I say, well, I'm saying that x is bigger than 3. Everything to the right of 3, everything that's bigger than 3. Everything that's bigger than 3. Can I be equal to 3? Is it a closed point? It is. So x is greater than or equal to 3. Final answer. I know it's a lot of work to get something so tiny, but there it is. My question for you now, before you try number 5 on your own, is what would happen if I changed this to an and? You still do the same equation, but when you come down here, it changes so that you're finding only overlap. Instead of doing an or, where you only need 1 line, which works there, now I'm doing an and, which requires 2 lines, and then the answer suddenly becomes everything from here to the right, not including 5. So that's the only change that would be made. It's how you interpret the graph and combine it into this answer. Alright, so you now need to pause the video, try out example 5 on your own, really work with your neighbors. Like, you might get this, you might be one of those students that's like, oh, this is easy. If you're that type of person, you need to help the people around you. I know this is a hard lesson. I know that there are going to be people that are confused. Be a leader, help your peers out, report it to the sub, report it to someone. That way you get your XP when Mr. Sindel comes back tomorrow. Alright, so you've unpaused the video now to see the video solutions. I'm trusting that you actually try this on your own. Again, you're going to add 7 to both sides here. Add 7, add 7. When I add 7 to both sides, I'm left with 4x because these 7's cancel out. Still greater than or equal, or still greater than, this is going to be 24. And then from here, I'm going to divide both sides by 4, divide by 4, divide by 4, and I get x is strictly greater than 6. So let's graph that. Strictly greater than 6 is an open point because it can't be equal to 6. And make my arrow, it's going to the right, so arrow going to the right. Alright, now I'm solving this one. So when I solve this one, I'm going to add 20 to both sides, add 20 to both sides. When I do that, the 20's cancel out. I'm left with 5x. I did not multiply or divide by negative in anything yet, so I don't have to flip the sign. It is less than, it's going to be 15 because they are different signs, negative and positive, so I subtract. 20 minus 5, 15, take the sign out larger, which is positive. And then from here, I'm going to divide both sides by 5, divide by 5, divide by 5, and x is therefore less than 3. Let's graph that. X is less than 3, so it's an open point because it's not equal to. And I'm making my arrow going to the left. And I need to now combine them using the word or. So using the word or, and I guess I could even look at my table again, I have a situation that's very similar to this. What happens when I combine that with or? It's the same thing, because the logic dictates. Or says wherever I have 1 line, that's a solution. So that's a solution, 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 that's a solution. But none of this is a solution because there's no line. So we can just say that is our final answer. And how do you say this? Well, whenever you have a gap like this, I come up here to my gap to look at the notation. You just write them down with an or in between. So I write them down. This black one over here is x has to be less than 3, which matches up right there. So good. And I have to say or. And I come back over here to my green one and I say x is greater than 6, which is exactly what I wrote over here. And there is my final answer. So my question for you before I end the notes is, what would happen if I change this to an and? What happens when I have this situation with an and? Try doing it without looking at your table on the front. Okay, maybe you had a look, but what did you get? If you actually check your work, here's your situation, and the answer is no solutions, because the logic dictates. And is looking for overlap. Where do I have 2 lines overlapping? Nothing overlaps, nothing overlaps, nothing ever overlaps for this one. So if I did and, it would be no solutions. But there's the answer for or. Alright, I know that was hard. Hopefully we'll be okay by tomorrow. Just let me know how it went. And that concludes the notes. You may begin the 1 assignment on Khan Academy.